Alright, so today we're going to talk about dividing radicals. And dividing radicals is very similar to multiplying in that you must deal with the coefficients, the number in front of the radical first, and then you can divide the inside of the radicals, otherwise known as the radicands. So if we take a look at example 1a, we have square root 48 divided by square root 6. Because the coefficients are both 1, we don't have to worry, and we can just say this is the square root of 8, because 48 divided by 6 is square root 8. For b, we have square root 10 divided by square root 40. Now, we know this is going to be a fraction, so 10 and 40, we can divide both of those by 10. So we have square root 1 over square root 4. Remember, we're just simplifying a fraction. And actually, the square root of 1 is 1, and the square root of 4 is 2. Now see, we do have to go back to step 1 where we divide the coefficients. So 16 divided by 4 is 4, and the square root of 15 divided by the square root of 3 is 5. For d, we cannot divide these because 2 is not in a radical, but we can simplify square root 12. Recall that we can break it apart into a product. So we can say this is square root 4 times the square root of 3 divided by 2. And we know the square root of 4 is 2, leaving the square root of 3. And now we can see, once we've broken our root 12 into 4 times 3 and evaluated the square root 4, we can cancel the 2's and we're left with square root 3. E, we have 6 divided by 3, which is 2, and 18 divided by 9, which is the square root of 2. For f, we have 10 divided by 30. So if I reduce this fraction, I would get 1 over 3, and root 50 divided by root 5 would be square root 10. Another way of writing it is root 10 over 3. And we can't simplify root 10 because there's no perfect square that multiplies to it, so we'll just leave it. For g, we can reduce this fraction by dividing the top and bottom by 7, so I get 1 over 2. So I divide this by 7 and divide this by 7. And 16 divided by 8 is square root 2. And again, another way of writing it is 1 times square root 2, square root 2. It can also be written as root 2 over 2. Because we are still multiplying, remember there's a 1 in the denominator. Be careful for h because it is a cube root. You can still divide the radicands, but let's start with the coefficients. So 20 divided by 5 is 4. Cube root 7 divided by cube root 56. Let's divide both of those radicands by 7. So we get cube root of 1 over the cube root of 8. Because 7 divided by 7 is 1, 56 divided by 7 is 8. We can reduce that fraction as well. And we know that the cube root of 1 is 1, and the cube root of 8 is 2. So we have 4 times 1 divided by 2, which equals 2. And last but not least, we have example I. So we have 3 divided by 6, so let's reduce this fraction by dividing the top and bottom by 3. So I get 1 over 2. 13 and 52, I can divide 13 by 13 and get square root 1, and I can divide 52 by 13 and get square root 4. So what I have on the top is 1 times the square root of 1, which is 1, and 2 times the square root of 4, which is 2 times 2. So our final answer is 1/4. Now, let's talk about when we get a radical in the denominator. So when you get a radical in the denominator, we want to do something that's called rationalizing. We want to get the radical that's in the denominator into the top of our radical. Okay, so when you're dividing, sometimes there will not be a whole number. And so what we need to do is we need to multiply the expression by a form of 1. because we don't want to change the expression, we just want it to look different. So take a look at the denominator, which is square root 5, and we're going to multiply the top and the bottom by square root 5. And what this does is, if you look at the denominator, we have square root 5 times square root 5, which is the square root of 25, or if you recall that the same number square root multiplied is just itself. And on the top we have 25 square root 5. So now we have rationalized the denominator. There's no longer a radical in the denominator. Let's do the same with example 3. So we have 3 square root 2 over 3 square root 2. This is essentially 1. We haven't really multiplied it by anything because 3 root 2 divided by 3 root 2 is 1, but this allows us to get the radicals out of the denominator. So when we do this, let's do the denominator first. We have 3 times 3 is 9, and root 2 times root 2, which is 2. And on the top, we're going to have to distribute. So 3 times root 6, sorry, 3 square root 2 times root 6 would be 3 square root 12. And 3 root 2 times negative root 5 would be negative 3 square root 10. Okay, now we're not quite done because we need to simplify. So the first term, we can break it up into 4 times 3, square root of 4 times 3. Second one, unfortunately, we cannot reduce. Okay, and the denominator becomes 18. So if we simplify 3 times the square root of 4 times 3, we get 3 times 2, square root 3, minus 3 root 10 over 18. And notice that we have 3 here, and we can also, we also have 3 that multiplies to 18, a common multiple. So what we can do is we can divide each term by 3. So when we do that, we get 2 root 3 minus square root 10 over 6. Now, if you left your answer at this step, you would almost be correct, but because the question does say simplify, you must simplify. Okay? So again, we broke apart our square root 12, took the square root, and then realized that each term, and every term, it has to be every term, is divisible by the same number, and so we divided each term by 3 and reduced. Okay? Now, something different happens when the denominator has 2 terms. So before we were dealing with a monomial in the bottom, the difference happens when we have a binomial in the bottom. So when that happens, we have to multiply by something called the conjugate. Okay? And the conjugate, for example, if I had 1 over square root 2 plus square root 3, the conjugate would be square root 2 take away the square root 3 over the square root 2 take away square root 3. So this right here is the conjugate. So it's the same as the denominator, but we change the signs. And the reason we do that is because if you recall back to multiplying, when you have the same 2 binomials multiplying, but different signs in the middle, then we get something happening in the middle where they cancel. So if we look at the first example, and then we look at the denominator, we know that the conjugate will be 3 root 2 plus root 3. That will be our conjugate. 3 root 2 plus square root 3. So let's go ahead and multiply by that. 3 square root 2 plus square root 3 over 3 square root 2 plus square root 3. You must multiply top and bottom because this essentially equals 1. Okay, so let's go ahead and multiply. So we have 3 times 3 is 9 square root 2. 3 times square root 3 is positive 3 root 3. In the denominator, we get 9 square root 4. 3 times 3 is 9, 2 times 2 is 4. Then we multiply the outsides. 3 root 2 times positive root 3, so plus 3 root 6. And we have the insides, negative root 3 times positive 3 root 2, so minus 3 root 6. And then last but not least, negative root 3 times positive root 3. So negative square root 9. And now we simplify. So the square root of 4 is 2. So we have 9 times 2 is 18. Then, this is where the magic happens. We have 3 root 6 minus 3 root 6. That all is canceled. Then we have minus root 9. Well, root 9 is 3. And I apologize, I should have written the numerator first. So we have 9 root 2 plus 3 root 3. And on the denominator, we have 18 take away 3. So our final answer would be 9 root 2 plus 3 root 3 over 15. And we can actually divide each term by 3, so let's go ahead and do that. Divide by 3. So our final answer would be 3 root 2 plus root 3 over 5. Okay, and so the same will happen for each one. So I'm going to let you try B on your own, and let's just finish up with C. So we're going to multiply by the conjugate of C. So we have square root 6 plus square root 10 over square root 6 plus square root 10. Okay, we must multiply the top and bottom by the same, and we multiply by the conjugate. So we get square root 2 times square root 6, which would be square root 12. Then we have square root 2 times square root 10, square root 20, plus 2 root 5 times root 6, is 2 root 30, and finally 2 root 5 times root 10, so 2 root 50. And in the denominator, remember, the middles will cancel out, but we'll write it anyways. Root 6 times root 6 is root 36, or you can just write 6 if you want to skip that step. Square root 6 times square root 10 is square root 60. Negative root 10 times positive root 6 would be negative square root 60. And negative root 10 times positive root 10 is negative 100, root 100. Okay, so let's take a look at, let's set up our fraction. Let's look at the denominator. We've got square root 36, which is 6. These two cancel out, and the root 100 is minus 10. On the top, we have to simplify each term. So square root 12 we can break into 4 times 3. Square root 20 we can break into 4 times 5. Root 30 cannot be broken apart. There's no perfect square that multiplies to 30. Root 50 we can break into 25 times 2. Okay. So now let's simplify even further. So the square root of 4 is 2, and we have root 3 remaining. Square root of 4 is 2, and we have 5, square root 5 remaining, plus 2 root 30, plus the square root of 25 is 5, so we have 2 times 5 is 10, root 2 remaining, all over negative 4. Now I can see there's a 2 here, 2 here, 2 here, and definitely a 2 within 10, and a 2. So let's divide by 2. Every term has to be divisible. So if I divide 2 by 2, I get 1 root 3 plus 1 root 5 plus 1 root 30 plus 5 root 2. 10 divided by 2 is 5. And then 4 divided by 2 is 2. And because it's more proper in math to write the negative at the front, I'm going to move the negative to the front of the fraction. And that is our final answer. So try B, and we'll talk about it in class.